going to do this extra review sheet with you. Okay. So first question says write the inequality. So I'm going to find the slope and the y-intercept, okay? The y-intercept is -1, and I find that right here. And then if I go up 2 and write 1, I do find the line again. So let me just make sure. Yeah. So I'm going to say that it's 2x. Okay. So now I'm definitely going to need the y. And it's shaded below, so that would indicate less than. And since the line is dotted, you don't want to put the equal bar here. So, I mean, you can basically pay attention to dotted line, and that would tell you no equal bar. And then shading up would be greater, shading down would be less. So you can pay attention to that. Also, the slope and the y-intercept. Okay, name the transformation. So remember, the parent function is always the absolute value of x, which goes through 0, 0, or the origin. And this one would have a turning point of +4, +7. So when the x is positive, that means that it's gone to the right. So that would be 4 to the right. And when the 7 is positive, that's the y. So that would be 7 up. So we would say a shift. You can also use the word translation of 4 to the right and 7 up. And you can double check this on your graphing calculator. All right, so find f of 3. So basically replace the x with a 3. So 3 subtract 2 inside the absolute value bars plus 7. 3 minus 2 is 1. The absolute value of 1 is 1. And 1 plus 7 equals 8. And again, you can double check this with your graphing calculator. Okay, for the function defined by. Now this is a piecewise function, so you do have to pay attention to the domain restrictions. So I am going to look here first to tell me which expression to use. So what it's saying is when x is less than 2, use the first expression. 1 is less than 2, so I'm going to use the first expression. 2 times 1 subtract 3. 2 times 1 is 2. 2 minus 3 is -1. And you can also use your calculator. So now for the 2, I'm going to use the second one, and that's because the second expression has the interval with the equal bar. So 5 minus 3 times 2, 5 minus 6, which is also -1. Coincidence. Okay. For the function defined by, and that's a piecewise function, what type of circle would be drawn at 4, 1? Well, 4, 1 comes from the first expression. That has 4, 1 as part of its solution set. So when I look at that, I'm looking to see if there's an equal bar or not an equal bar. If there is no equal bar, that's going to be an open circle. And then 4, -3 is part of the second expression. And that would be a closed circle. So it's basically paying attention to the inequality symbols. When you have something without an equal bar, you want to do an open circle. When you have something with an equal bar, you want to do a closed circle. According to the graph shown, find the value of f of 1. So remember, it's always f of x. So we're basically saying that x equals 1, which would be right here. So therefore, the value of f of 1 is equal to 0 because they're looking for the y value. Is the mapping diagram a representation of a function? No. It's this double arrow right here coming from the 2 that is a violation. Each input can have only one output. So it's the double arrow coming away from the 2 that makes this not a function. All right, graph the function. So I'm going to start with the vertex, which would be -5, because remember when it's in between the absolute value bars, it's almost what we call counterintuitive. When I see that, I see +5, but that means that a -5 was what was subtracted. And then outside the absolute value bars, it is the same thing. And that comes down to the formula. It is x minus h inside the absolute value bars, and then after it's plus k. So that's the vertex. And again, you can use your graphing calculator. If you don't feel confident, that's okay. Use your graphing calculator to help you build that confidence. Okay, so that's going to be right here. And what I always do is I just make that my center. And I go a little bit smaller and then a little bit bigger. And you can get all the values straight from the graphing calculator. Okay. So this is going to be -1. This is going to be 0. And that's actually a good point to have because it helps answer questions. And then this is going to be -1, and this is going to be 0. Okay, so I'm going to graph this. Okay. And then I'm going to graph this. All right. And you can always use a ruler to help you graph things better. So the domain, you're going to look from the left, which is -infinity, to the right, which is +infinity. The range, you're going to go low to high. So the lowest number is -2, and it doesn't stop. So that's infinity. Okay. And again, you can check this on your graphing calculator. Calculate the average rate of change from 2 to 5 seconds. So that's just going to be the slope formula. The change in y over the change in x. y2 minus y1 over x2 minus x1. So I'm just going to put this in my calculator. For my numerator, I have 4.32, and for my denominator, I have 3. And that's going to give me an average rate of change of 1.44. Okay. So I'm graphing this inequality, and one of the first things that I would want to do is put it in that y equals mx plus b form, slope-intercept. So I'm going to move the 4x by subtracting. The opposite of adding is subtracting. I'm going to divide by -6. So that's going to give me, and I'm going to write it up here, y. Since the 6 is negative, I have to reverse the symbol. And that's -2 because positive divided by negative. So I'm at -3. Oops, nope, sorry, -2. And I'm going up 2 over 3. Up 2 over 3. And you can use your calculator to confirm points. All right, so this is going to be a dotted or a dashed line. And that's because there is no equal bar. And since it says greater than, I'm going to shade above. Okay, name one point in the solution set. I'm just going to grab 0, 0. Name a point not in the solution set. I'm just going to go over here, 10, 0. So remember, anything in the solution set will work. Anything not in the solution set will not work. Dotted lines are not included. Solid lines are included. Okay, so Maddie is walking from home. So this is important because if he's walking from home, That's where he starts. Distance from home is 0. If it says he's walking to home, he would start further away, so you would be up the axes a little bit. He walks at a steady but slow pace since he's talking on his phone. It takes him 6 minutes to walk 3 blocks. So 6 minutes, 1, 2, 3 blocks. Okay, steady but slow. He sees his friend Charles and decides to wait for Charles. He waits for 4 minutes. So 1, 2, 3, 4 minutes. So now 10 minutes has passed. And you can always double check that because it's like, oh, okay, here's 6 minutes. Here's 4 minutes. I should be at 10, and yes, I am. Together, they walk the rest of the way to practice. They walk at a rate of 2 blocks, so up to for 3 minutes. 2 blocks every 3 minutes. 2 blocks every 3 minutes. And does that for 9 minutes, so he's at 19 minutes. All right? And that's the walk. All right, so now we're on to piecewise. I would strongly suggest that you make a table for each piece, and that could help you. So I'm just going to do piece 1. And it says x is less than -3. So I'm going to do -5, -4, and then -3. So I choose numbers that work for the inequality that represents the domain. So now I'm going to substitute in these numbers, and this gives me -14, which isn't such a great number because it's not going to fit. And then this gives me -12, and not so great because it's not going to fit, but we'll work it out. And then this is going to give me -10. So, it's just not such a great question because those don't fit. But -3, -10 is down here. And then the others would be off the page, but I'm just going to sketch them in. Okay, so now it's an open circle, and it's going in this direction. And, hopefully the other parts will fit. Okay, so now it's saying from -3 up until 2. So that would be -2, -1, 0, 1, and 2. And this is actually easy to graph because it's just saying the answer is always 2. That's that horizontal line. So I'm going to go to -3, 2, and I'm going to make a closed circle. The circle is closed because the inequality symbol has an equal bar. And I'm going to plot those points. And again, this is a closed circle. So remember, this is similar to the AND statement, and the AND statement would have 2 closed circles. Okay, now I'm going to make my third one. And it says, I'm going to put the X and the Y here just to make it better. You could also use different colors if that helps you. I probably should have done that for you to help you a little bit. So this is saying 2 and greater. So 2, 3, 4. Okay. So when I plug in a 2, that gives me 2. When I plug in a 3, that gives me 0. When I plug in a 4, that gives me -2. And you can put as many points as you want to help you. And you can also use your graphing calculator. Okay, so that's going to be 2, 2. And that's going to be an open circle, even though it doesn't really matter because there's already a circle there. But then 3, 0. And that is going to have an arrow. So when you look at these inequalities for your domain, try to think back of what they looked like on a number line. So on a number line, the first inequality, that would be an open circle with an arrow. And the second one would be 2 closed circles. And then the third one would be an open circle with an arrow. It is going to have that similar look. Okay, so it ends up looking like this. All right, well, good luck on your test tomorrow and happy studying.